Hi guys, the last thing that I just want to quickly talk about before you can try activities is notation. Okay, there is a way in which we represent functions algebraically, there is a convention that we use. Maybe to start with, let's talk about mapping, because that's what really a function is, more or less. It's just a mapping. Okay, as I said, the mapping happens where? On the Cartesian plane. Okay, you remember that, right? All right, so now if I want to represent a mapping, I can say, well, I've got a mapping called F. What it does is it maps X values in this fashion by multiplying those X values by 3. That's a map. Now, in functional notation, maybe I must write this down. In functional notation, what happens is I can say, well, this is f of x is equal to 3x. Now, what is nice about this functional notation, unlike having a y, is that it tells us that this thing, f, really depends on x. For you to get what f is, or the result, you must put in some number for x. And what will you do to that number? This is the process. Okay? The process is that you multiply it by 3. At this point, guys, we know, I hope you have checked that by now. You have realized that this is a linear function, okay? And I think you are now starting to make sense of what I said earlier on as I was saying function, or linear function. All right, so this is the notation that we are going to use now and then when we refer to functions. So let me give you an example. Let's just play around this notation so that you can internalize it. Suppose I give you a mapping and I said, well, f of x is x plus 2. Well, this is in functional notation. Then I say to you, find f of 1. What then this means is, oh, okay, maybe let me write down all the questions. After f of 1, find f of minus 2 and find f of 0. So if we were to answer this, then it means for f of 1, I'm just going to go and take my formula or the notation and say, okay, f of 1 is where I see x, I must put a 1, so it's 1 plus 2, and this is 3. And then for f of minus 2, I'm going to have minus 2 plus 2, and that's a 0. And for f of 0, I'm going to have 0 plus 2, and that's a 2. And that's how easy it is to deal with this. Then what you can do, you can actually now represent this also on the Cartesian plane. In this case, f of x represents y. So it's the y-axis, and then obviously x will be on your x-axis. So guys, we're gonna do some practice on these things, how to go about them and all that. I want you to get used to actually this way of writing things, functional notation, so that you can actually start internalizing it, because in grade 12, even in grade 11, we start using it more and more and more. So you need to now start building this solid foundation in your minds. Okay, so let's take the last one. Maybe let's suppose we have a function g of x. So this is to say to you, it will not always be f. It can be any other variable, g of x or h of x, s of x, p of x, whichever way, just be used to it. Okay, let's say it's minus 3x plus 2. Remember, the mapping for this will be, you've got a function g, and it maps x values in this fashion, minus 3x plus 2. That's another way to write it, okay? This in the mapping form, this is the function notation form, all right? So let's go ahead now and find some interesting things. What is g of -1? What is g of a half maybe? And what is g of a maybe, and what is g of minus x, and perhaps we can introduce this and say, what about g of x plus h, and what about g of x plus h minus g of x? So let's have some fun and do this. In this case, g of -1, I have -3, I must put a -1 where I see the x, plus 2. Then this is negative times negative. Remember your multiplication, you have to use SNL, that is signs first, numbers second, letters or variables last. So signs positive, okay, because negative times negative is positive. 3 times 1 is 3. There are no letters, so we are done. Plus 2, and so that's 5. G of a half, I'm going to have -3, put in a half, add 2. This is -3/2 plus 2, and you can see that's the same as 4/2, and so the answer here is a half. And finally, g of a, I have -3. I put an a there, plus 2. This is simply -3a plus 2. G of minus x is -3. I substitute minus x plus 2. This is 3x plus 2. G of x plus h, again, -3 into x plus h equals to -3x minus 3h. Now, I already know what x plus h is, so I'm just going to write here -3x minus 3h minus what is g of x? G of x is -3x plus 2. Notice the importance again of putting brackets. Then -3x minus 3h plus, now multiply that signs, okay, x, remember there's just -1 here, the invisible math, okay? If you want to know invisible math, just check the senior phase videos that I've put up also. So that's going to be plus, and then this is going to be -2. And that's about it. Well, not really. We've got like terms here, actually. 3x takes care of the 3x. So your final answer is -3h minus 2. Very, very important, guys. I hope you pay attention and you start looking at this. We are now going to look at each function, specifically how it behaves, how the parameters behave. For example, like the linear function, we have analyzed it already. We are now just going to have some fun. Hope you enjoyed. Cheers.